All right, let's dive into a topic that I know can look super intimidating in algebra, adding and subtracting rational expressions. But I promise you, by the end of this, you're going to see it all boils down to one simple idea you already know. Let's get into it.
So take a look at this. Yeah, this is the kind of problem that makes you just want to shut the book, right? You've got variables, you've got exponents, fractions, it's all one big jumble. But what if I told you that in just a couple of minutes, you're going to have the exact tools to solve this thing piece by piece? Because that monster of a problem, and honestly, every single one like it, is totally controlled by one single fundamental concept. You get this one rule down, and everything else just clicks into place. And here it is. This is the golden rule. It's the exact same rule you learned with regular old number fractions, probably back in elementary school. If you want to add or subtract fractions, the bottom parts, the denominators, have got to be the same. Period. No exceptions. This is the key to this entire process.
Think about it like this. On the left, with simple numbers, you know you need to find a common denominator, in this case 12, to solve it. Well, on the right, with all the algebra, the principle is exactly the same. The pieces look different, sure, but how you play the game is identical. So let's start at level 1, the absolute basics. We're going to look at problems where the denominators are just simple numbers or these single-term expressions we call monomials. Okay, let's take our first one, 5 over x plus 3 over x squared. So to follow our golden rule, we need those denominators to match. We've got an x and we've got an x squared. So what's the smallest thing, the least common denominator that both of those can fit into? Well, it's got to be x squared. Now check this out, especially step 2. The second fraction already has our target denominator, x squared, so it's good to go. We just need to upgrade the first one. We do that by multiplying it by x over x, which is really just a sneaky way of writing the number 1. It doesn't change the value, it just changes how it looks. So we get 5x over x squared, and now that the bottoms match, we can just combine the tops. That's it. Okay, let's try another one. This time, our denominators are just the numbers 4 and 3, so our LCD is going to be 12. Easy enough. But wait. There's a trap here, and it's that little minus sign sitting right in the middle. This is where almost everybody makes a mistake. And this is the absolute key. Just like the quote says, that negative sign has to be distributed. You see, after you build up that second fraction, the top becomes 4x plus 8. But that negative sign out front applies to the entire thing, so it becomes minus 4x and minus 8. Forgetting to distribute that negative is the number one error, so always watch out for it. All right, level 1 complete. Time to level up. Let's move on to level 2, where things get a little more interesting. Now the denominators themselves are going to be algebraic expressions, specifically binomials. Check this out. The denominators are x minus 2 and x plus 2. They look kind of similar, but they are totally different expressions. So how in the world do we find a common denominator? Well, when you have two totally distinct things like this, the easiest LCD is simply their product. You just multiply them together. So it's x minus 2 times x plus 2. And this lays out the whole process perfectly. You just give each fraction the piece it's missing. The first fraction needs the x plus 2, so we give it 1. The second fraction needs the x minus 2, so we give it one of those. Once the denominators are the same, we just multiply out the tops. We get 4x plus 8 and 5x minus 10, and then we just combine all the like terms to get our final answer. And now it's time for the final boss, level 3. This is where we circle all the way back to that scary-looking problem from the very beginning. And the secret weapon, the key that unlocks the whole thing, is one of the most powerful skills in all of algebra: factoring. This quote really says it all. This isn't just a friendly tip. It's a non-negotiable rule. If you see a big, messy polynomial in the denominator, your very first instinct, before you even think about anything else, has to be factor it. And here's why. These are the two denominators from that first problem. In their original form, they look like they have nothing in common. But watch what happens when you factor them. You break them down into their building blocks. And there it is, the aha moment. It turns out they both share a piece of DNA. They both have an x plus 4 term. This is the magic of factoring. It reveals the hidden connections. So instead of multiplying those giant polynomials together, we now see that our LCD just needs one of each unique piece, an x plus 3, an x plus 4, and an x plus 5. This makes the problem so much easier to handle.
So after we build up each fraction with its missing part and carefully combine the numerators, the top actually simplifies in a really cool way that lets the x plus 4 terms cancel each other out, leaving us with this nice, clean final answer. We just solved that monster problem. Okay, before we wrap it all up, I want to share one pro tip for a really tricky case that can save you a ton of work. I like to call it the opposite denominator trick. So every once in a while, you'll see denominators that are opposites, like x minus 4 and 4 minus x. They look different, but they're basically just mirror images of each other. They're only off by a factor of -1. If you pull a -1 out of 4 minus x, you're left with -1 times x minus 4. They're practically the same thing. So in a problem with denominators like that, all you have to do is factor out that -1, which flips the sign in the middle of the problem, and poof, just like that, with no complicated multiplication, you have a common denominator. It's such an elegant and powerful shortcut. Okay, so we've gone from the basics to the step-ups to the big challenge level, and we even learned a pro tip. Now let's put it all together into one universal toolkit you can use for any rational expression problem you ever see. And here it is, your 5-step guide to victory. 1. Factor first, factor always. 2. Look at all the pieces and build your LCD. 3. Give each fraction whatever parts it's missing. 4. Combine the tops, and please, please, please be careful with those negative signs. And 5. Always check if you can simplify at the very end. This process will work every single time. So just think, you started out looking at a problem that probably seemed impossible, and now you have a 5-step toolkit to solve it and any others like it. You've definitely leveled up your algebra skills today. The only question left is, what challenge are you going to take on next? Thanks for listening.